the demo of how RGB works, I would like to show a simple wallet that allows do the basic transfers of RGB tokens. This wallet was born as an attempt to apply the existing RGB system protocol and libraries to the real wallet case. Before the new year, we were able to develop end-user software for token issuance. And currently, I'm working on end-user software for transfers of assets, and this is actually the wallet. This work is quite important in terms of that, of course, RGB were never used before, and creating the first application using RGB, I discovered a lot of issues, optimizations that has to be applied for the API, and even parts that were lacking from the API. So if you will look at the history of the GitHub commitments, you will see that for the last 2 weeks, there were only 6 commitments to the RGB core library and RGB node, and there was a lot of them. On the other hand, so all these commitments are coming from the fact that I'm actually finalizing the wallet using RGB, and this wallet is it's not a product by LNPBP Standards Association, it's a more product by my company, but the main idea of doing this wallet is basically make sure that RGB works in practice. The wallet is called MyCitadel, and it will support Bitcoin, Lightning Network, RGB on-chain, and RGB over the Lightning Network. In the first version, it will support only fungible tokens, but later on, we plan to add NFTs and identities there. The wallet is organized. I will start with a small slide. The wallet is organized. Not that. Screen sharing, sorry. Yeah. The wallet organized in modular way that allows gradual development and early experiments. Of course, there will be end-user facing applications for mobile, iOS, Android, and desktop. Additionally to that, there will be a command line interface, and actually it will be a command line interface showing that I will be showing today. The most important part that all these are just interface wrappers. They have the mobile specific code and command line code and desktop code. They don't have any business logic at all, aside from the keeping the private keys. I will explain why it goes into the user interface part. And all of them are using and talking to MyCitadel node. And this is the same type of node as RGB node and LNP node. And the goal of having a MyCitadel node is to manage the complexity behind merging 3 parts together. The first part is RGB client validated data. The second part is Lightning Network channel state. And the third part is wallet-specific data, which are related to keeping track of the UTXOs, to the descriptors, and everything that is neither RGB nor Lightning Network related, and the normal actual business logic of any wallet. And this node is written once, so the whole business logic is there. It's written in Rust, and available on this link, which I will share with you. And for any wallet developer, this should be a reference implementation and the reference code of what you actually have to do in order to use RGB together with the Lightning Network, together with a Bitcoin. So basically it shows what you have to add to the wallet, additionally to the Bitcoin specific part, in order to support RGB. And from my experience working on this part, I have to say that a lot. Unfortunately, most of the time, over the last week, I spent on the Bitcoin part, non-RGB part, because it happened that we are still lacking a lot in the Rust for doing a proper Bitcoin wallet. especially if you need to integrate it with the Lightning Network and be able to support many RGB specific stuff. So basically, I ended up creating a Bitcoin wallet library that can work without Rust Bitcoin wallet library that can work without RGB, but is RGB compatible. This wallet library called Descriptor Wallet, and it's part of the association, LNPBP association code. So anybody, all the wallet developers doing Rust wallet development are free to use it without any limitations. I'm posting the link. Just a second. Here it is. And yeah, it has taken the most of the time. The time for RGB integration was much, much shorter. So why I have this shared node, which is separated and accessed from the user interface via RPC calls? There are two main reasons. The first one, you can run all of this, RGB embedded RGB node, embedded Lightning node, MyCitadel node, right inside the mobile and or on the desktop. So it's a single process, multi-threaded process, but it's a single process. But at the same time, you can externalize RGB node and LNP node if needed, or even externalize the MyCitadel node. So you can run, for instance, on your personal server, MyCitadel node managing RGB node and LNP node, and have a multiple devices like iPhone, iPad, your desktop, that will be talking to the same node and demonstrating the whole metadata and operation history and the wallets that are actually, if you will do a transaction and provide some description to this transaction on one device, all other devices will be able to see that. If you import information about RGB assets, other devices will be also able to see that. And especially that can be important in the case of enterprise, where you may have corporate accounts shared and accessed by multiple people inside the company. So that's why I have used this node-based design. The code of the node is here. And here is the actual code of this node. I have to say that for the wallet developers, I was a bit impressed by the amount of customization you need to do in order to work with the client validated data. Because basically you have many concepts that are not used in the Bitcoin world and not used by Bitcoin wallets. Let me just give me a second. I will open the main code part. So, for instance, this is probably the most important part of the story when you compose a payment. And this business logic allows you to create either Bitcoin or RGB payment. So it works the same way when you do a Bitcoin transaction or RGB transaction. However, for RGB transaction, unlike normal Bitcoin transaction, you need to do a few very specific things. The first thing, you need to create a commitment inside the Bitcoin transaction for the RGB transfer. And this commitment goes to very specific output, and you can't actually change the number of output into which commitment goes. And for that output, you need to know the public key, because usually in output, you put a hash of public key. And you need to, inside your wallet business logic, you need to be able to find the information about the public key that will go into that output. Also, you have a special mechanism for creating RGB change, because basically you will have two concepts, Bitcoin change and RGB change. When you do a pure Bitcoin transfer, when you do an RGB transfer, you still need to spend outputs that contain Bitcoins, because you can't have an output without Bitcoins. And you need to put that Bitcoin somewhere. And if you're not transferring Bitcoins, you need to basically create an output where you will be paying change back to yourself. And at the same time, when you transfer RGB, you will be probably spending more than you're sending. So you need to create RGB change as well. And you have these two levels. And this RGB change can be allocated to a different transaction, to existing transaction output that you already own, or to the transaction output inside the new transaction that you created. So this all can be configured. And what I managed to do, what it was important for me, is to make sure that this reference implementation, this code, allows arbitrary complexity. So all cases are covered. This code currently covers cases when you pay RGB change to existing UTXO or inside the same transaction. This covers the case when you're creating RGB transfer and the other party has provided you not with a UTXO, but with a descriptor. So you're paying that party both Bitcoins, small amount of Bitcoins, called giveaway here. So we have this transfer info thing, and there will be giveaway field. So you will be able as a payer to choose how much Bitcoins you will pay for the other party, such this RGB funds goes actually inside the transaction output. And it is able to tweak the public keys as required and to do all parts of the transfer. So there are phases where you collect RGB inputs, collect inputs for the transaction you create. Then you construct outputs for the same transaction. Then you need to construct an Bitcoin change output. Then you need to construct not an output, but the structures for RGB change, which may be a Bitcoin transaction output or maybe an allocation to existing UTXO. You can develop coin selection, different coin selection strategies. Here I'm using very simple one, but this, for instance, single line, when I'm just sorting with the reverse order all of the amounts. So I'm starting with the smaller amounts. You can replace this logic with a different coin selections, which take into account both how much are RGB assets and Bitcoin assets you will have. This code works with the multiple RGB assets on the same output, so it allows you not to lose all those assets. So basically it covers all the complex cases that may happen with RGB. And finally, you construct a Bitcoin, partially signed Bitcoin transaction where you provide the necessary information to keeping the tweaking. Also, this PSBD, unlike normal Bitcoin PSBD, must have the information about the fee. So you need to include the full source of the transactions according to PSBD specification from the inputs. So you need to include the source of the transactions outputs of which you are spending. So this all affects the internals of a wallet, and normal wallets do not do that. So I hope this work that I did will help them understanding how actually they need to modify the business logic of their wallet in order to support RGB. So I will show how it works. And I will start with how you can install this. Basically, you need to git clone the repository. So I'm right now already in the cloned repository. We have a number of directories here. So this is the actual server part, the node. This is the client part, and which you will be using if you will be integrating this from the mobile devices. And also there is a storage and cache. The difference how the actual data are kept across the wallet is also quite important for wallet developers. RGB node keeps two things. First of all, it keeps RGB stash, which shouldn't be lost. And this stash data should be backup. These are binary data. You can't draw much of information from there, but you need to keep them in order not to lose RGB assets. Addition to that, it keeps RGB cache, which can be deleted or purged. It is basically a parsed information from the stash to save some time when it answers the question about assets. LNP node also maintains data, and it's actually channel state. The normal data maintained by any Lightning node, and it's not RGB related. However, additionally to that, the wallet node has to maintain two other sets of data. The first set is read-only wallet. Basically, it's a data that allow you to track on-chain transactions happening regarding the wallets, and information about which extended public key and how they are structured into wallet descriptors and spending policies. So this data are kept by the node. You also need to keep the invoices that you created, otherwise you wouldn't be able to accept UTXO-based RGB payments. Operation meta information, past or partially signed Bitcoin transaction that you signed, and so on. Additionally to this data, you also keep wallet cache, and this is actually, because you will need to talk to Electrum server, this is actually a cache of the data you will receive from Electrum server, from Bitcoin blockchain via Electrum server, and it also saves you time from accessing blockchain information. It is important that this node doesn't work with the private keys. Why? Because the storage of private keys is recommended to do platform specific. For instance, in mobile devices, we have a special secure vault or storage created by the mobile manufacturers. For instance, in Apple, on iPhone, you have a special chip that is able to store private keys, and it is advised to keep a seed phrase there. So that's why you can't store that inside the Rust code on the library or on the node itself. You need to use platform-specific way of keeping the private keys. And that's why this part is also separated. And here you get the partially signed Bitcoin transaction, but you need to sign it elsewhere, which the signature code will be a platform-specific code.
Can I interrupt you for a question, please?
Yeah.
Can I go back to the slide?
Yes.
I have a question regarding the seed storage. So my question is, if you store the seed on your device, it by default means that you need to trust your device, right? And we are part of the community which does not trust the devices that they have or own, especially if they are manufactured by Google or Apple.
Well, you have to store the seed somehow. And it's up to a specific user interface and policy of a wallet how to store the seed. It's important that the seed is not stored by the node itself, wallet node itself. And this gives you a freedom to store the seed on the hardware device, for instance. Or you can have a dedicated server that does the signatures with a special policies, like most of exchanges they have. You can have even multiple servers creating a multi-sigs on your transactions. And with this architecture, it gives you ability to apply the wallet to all these cases. So because the private keys are abstracted away from all the other parts, it doesn't matter actually when they are kept. The core idea is that they shouldn't be kept on the disk on the device. They should be kept either on the mobile on a specific storage, or on, if you don't trust the device, on the hardware device, or on the special signature creating server with the HSM, or as a multi-sig across multiple devices, hardware units, and servers. And this architecture allows you that type of flexibility.
Okay, got it. Thank you.
So both each Bitcoin transaction, each Bitcoin payment, and RGB payment will end up in creation of unsigned PSBT data, and then you will take this data and pass across your signers. There could be a co-signers or hardware devices or servers or locally stored seed. That is the second part. And when the transaction is signed, you basically publish it to the Bitcoin network, and then it is mined. That's the workflow. Okay, let's move to the demo. You need to do a cargo install inside the directory with the repository that you copied from GitHub. So you basically do this command. I have two consoles here, one for my local machine, because I already installed, so it runs really quickly. One for my local machine, one for the server. It's Alice and Bob, and I will show how they actually can interoperate. The command to work with a MyCitadel from command line called MyCitadel. And you have a number of subcommands to work with addresses, with wallets, with invoices, and so on and so forth. Assets. You start with creating a wallet. I already pre-created a few of them. So I will list the wallets that I have. For each wallet, I have a wallet identifier, a descriptor defining the spending policy. And this descriptor actually contains extended public key with a derivation path that should be used. I have deliberately taken these public keys from the Electrum, so I would be able to monitor the actual balances with a read-only Electrum wallet as well. And you can use different forms of descriptors like pay-to-key hash, SegWit, or not currently Taproot, but once the Taproot will be finalized in Vast Bitcoin, even Taproot. So I expect that this will be the first wallet to work with the Taproot. For each wallet, of course, you may have a balance, and the balancing operation for getting the balance, you need to specify the wallet you would like to query the balance. Here I have Bitcoins and RGBs, so I will probably start with wiping everything out. The actual data are stored in the directory when you work on the desktop, so you can easily check those data. Here is the data directory for the wallet. There is a subdirectory for each type of network you're working with. And there are data for RGB node, which is basically a stash and assets information, normal from RGB node, because MyCitadel runs embedded RGB node. And there are these data for the actual wallet information and cache as shown here. So this all blocks are clearly distinguishable. We have asset cache, RGB stash, read-only wallet data, and wallet cache. Here are these four things. Assets is actually asset cache. So if we will look inside the file, we will see that it's in a YAML format. There is a way of how you can configure it to be a binary data, but for debug purposes right now, I'm using YAML format. But this can be changed with a configuration option. And for each contract, each wallet is defined by a contract. It has ID. It has dedicated to some test, to some blockchain, spending policy based on description, state for using schemas in Taproot once they will be out there. Information about blending factors that were used during the invoice creation, the actual invoices that were created, and so on. And also there is cache data that allows you to cache the information you get from the Electrum server. So right now I will be removing this directory to start from scratch. As we see, there are no wallets here. So let me try to create a wallet. The form for the wallet creation, I need to specify the type of the wallet, single sig in this case, and I need to provide an extended public key that will be used for creating a single sig wallet, and a descriptor that actually formats the derivation for this public key. So I will go to Electrum, get the information here, copy the public key, extended public key, and create M0 equals, sorry, I need to put square boxes, then 0 and wildcard, because it's how Electrum structures its own wallets. If you will see the information about the first key, you will see that this is the abbreviation path it uses, and it increases this number with each turn. So I will use this one. Also, I need to provide a name for the wallet. I don't remember before the This will be electron wallet. And that's all. And I can also customize the chain on which this wallet should be used. In this case, it will be a testnet. Something got wrong. I think I need to have a hardened. Yeah. So the wallet is created. This is an ID for the wallet, and if I will list the wallets that I have, I will see it in this list. However, there will be no balance because I haven't synchronized with Electrum server. And to synchronize, I run a rescan command, which actually talks to Electrum server and checks for the assets that I have. And now it doesn't work. Interesting why. Probably do something wrong. In testnet, correct. Extend the Electrum. You can run with debug flags to see all the information that how the synchronization actually happens. I probably used something wrong in the derivation path or something like that because I was creating it right before. Oh, right. This is why. It's SegWit, while the wallet here is non-SegWit wallet. So I have created it in a wrong way. That's why it doesn't see the path. So I will create, once again, the same wallet, but specifying that this is a non-SegWit wallet. Let me check the option that I need to provide for that. Can you run help? Legacy. Yeah, I need to say that it is legacy. Here. And now I have a different wallet. So if I will do a list command, I will see the two wallets with a different descriptor here. And I need to check the balance for the legacy one. None. And if I will rescan here, so I see the Bitcoins that I have. The asset ID for Bitcoins is a dump asset ID. It's basically all zeros represented by Q in back encoding. So this stands for Bitcoins. And if I will check 8593, I will see that, yes, I have 8953 here. These are change addresses. They're not seen because they are using a different derivation path with a 1, and it's not part of the descriptor, so they are not seen by the wallet. Next, I need to add an asset to this wallet, and for doing that, I will issue an asset. Well, actually, I will use already issued assets to make it the story shorter. I have already issued an asset for this output, this one. So I use Bitcoin Core, Bitcoin Pro for doing that. I assign the initial issue to this output. Then I copy the Genesis data. And what I need to do is to import the assets. So right now, I don't have any. Now I can import it with the Genesis data. And here the asset. So if I will check the balance, even without rescanning, I wouldn't see it. But if I will rescan, I will see that I have some millions of this asset. This is the asset ID, C2VF8, C2VF8. So it found its own asset. On the contrary side, if I will import the asset without owning the wallet, here I have, I don't have this wallet. As you see, I'm using the different pub key. This pub key ends with a VVV, and this pub key here ends with a Oh, also www0, www1. So this uses change addresses from Electrum. And if I will check balance for this wallet, I will see the different balance. And this asset, I have no balance because I don't own the output even after the rescanning. I have another asset here, but for this asset, I don't own that initial issue as I own here. It's actually from my previous transfer of the asset. So now I have an asset. I would like to make a transfer. So I'd like to receive the asset named ending with the L8D. L8D. I would like to receive it on this wallet. So what I will write is invoice create. Let's see what I need to provide for the invoice creation command. I need to provide wallet ID and amount. So I have a wallet ID. I have, no, it's asset ID. I have wallet ID. Oh, it's asset ID. Here it is. Wallet ID, I need amount. Let's say I would take 543 something. And then I need to specify an asset, because otherwise it will be invoice created with Bitcoins, actually testnet Bitcoins, which I don't need right now. And this is a demonstration of how this new universal Bitcoin format is working, invoice format. So I'm creating this invoice, and this invoice is basically a back string. We had a presentation on some other call showing how the new invoicing format works. So I can parse, get the info about this invoice to see what parts of it are there. I need to provide tabulation format. So I have information about genesis of the asset actual ID, amount of the ID asset I would like to transfer, and the blended out point to which I would like to receive that transfer. So I copy this. To the Alice wallet, and I need to say that I would like to create pay invoice. For paying invoice, I need to provide the information from which wallet I will be paying, from this, because the other one doesn't have anything to pay. Before that, I need to provide an invoice itself. So I'm paying this invoice with this wallet. I need to provide how much fee I would like to pay. In this case, it will be 10. And I'm ending up creating a partially signed Bitcoin transaction and the consignment, which I need to send to the other party. So with a partially signed Bitcoin transaction, I need to create a signature. With a consignment, I need to copy this consignment and send to the other party. Once I signed this partially signed Bitcoin transaction, spending that specific output, I already actually have it signed because I just didn't publish it, because the keys they are not in the command line interface. They will be on the mobile, in the mobile version, but not in the command line. You need to use Electrum or any other device that keeps private keys and you trust with. And to accept that payment, so I will send the transaction to the Bitcoin network, and to accept the payment, I need to go back to the Bob wallet and type MyCitadel invoice accept and type the consignment. And that's all. Actually, what I just did is I did a verification of this consignment, and after the successful verification, I merged this request into the stash. If I will look into the same operation with debugging flags, I will see all this happening. So those of you who are interested, you can really dig deeply into how the whole workflow evolves. If I will check I'm not providing, you see, I'm not providing here neither wallet where I would like to receive the payment, nor the information about the blending secret, like I was doing with the RGB node. Why? Because these parts are managed by MyCitadel. MyCitadel keeps track for all invoices that it has created, keeps track of the blending secrets. I will show you here in MyCitadel directory in testnet. Inside the data file, I have blending factors for the invoices that I was creating, and it checks the output from the outpoint from the consignment and finds the matching blending factor. I do not provide the information about the wallet where I do receive, because the consignment can contain multiple transfers and it can be related to multiple wallets. And the wallet business logic analyzes all of that, and it will be able to see which transaction output belong to which wallet and display the appropriate part of this information inside the specific wallet. That is the other reason why wallet business logic and RGB node are separated, because RGB node keeps stash client validated data, which may apply to multiple wallets, or even keep information about the assets that are not owned by any of the wallets from the current user, such that if the user later will add more wallets and more descriptors, he will be able to see them without doing anything. So if I will do MyCitadel balance wallet list first, then balance for this wallet, wallet balance, balance. Three to one. So I don't see this here yet. But if I refresh and synchronize with Electrum, I will get this amount that I just transferred to myself from one wallet to another. Of course, this is unusable from the command line. Well, it can be used by, it takes a lot of attention to properly type in all the commands, cut and paste, and so on and so forth. So this is a primarily debugging tool for myself, and for those who would like to dig into the actual guts of how the RGB works together with Bitcoin and how you need to structure the wallet. The next week, I will be doing a different demo where I will be showing how the same MyCitadel node works inside the iOS mobile application with the end user interface, where all this complexity is basically hidden under the cover. And that would be the first announcement of that wallet, and we will be inviting everybody for closed testing because it's an Apple platform. We will publish it to App Store, and we will be able to add several hundreds of those who has Apple ID, iPhones or iPads, and would like to test the wallet. The actual interface will run on iPhone. It will have iPad version at the same moment because it's done with this new Swift AI. It just basically works on all platforms. And it will have also a Mac OS desktop version. So we'll be happy to see you next week for that demo.
Wonderful.
Awesome.
Thank you.
Looks really neat.
Sorry?
I just said it looks really neat.
Thank you.
Okay, so do we have any questions, guys? Okay, then I'm stopping the video recording.